So in this video, we're going to modify the shooting mechanism for our project, because currently we have it set up so that we shoot based on WASD. We move with the arrow keys. What we're going to do is forget about using the arrow key or WASD to shoot. We could even set up WASD as moving left, right, up, and down. So you could use either option if that was something you wanted to build into your project. So you could just simply, instead of having WASD like that, you could go and so double ampersand, because we're doing a compound conditional. Oh no, not double ampersand, double pipe, because it's or. So if it's 37, or if the key code is equal to 87. Oh no, that's not left. Left is A, so that would be 65. And need to change that O to, or 0 back to an O. So we could set it up and do it this way if you're so inclined. I'm just going to leave it. Leave that up to you. So we're not going to worry about having WASD because we're not going to use them anymore. What we're going to do is modify the projectile. Now the projectile, instead of moving in the cardinal directions based on what we're shooting, we're going to shoot it at an angle based on where the mouse is in relation to the player. So we need to have two floats. One will be our speed, and one is going to be the angle that we are using. Now we need to define those at the end of our constructor here. So then we'll go speed will be equal to 10. And this kind of matches what we're shooting here, where, I mean, could have used a variable of speed there in the first place, and we wouldn't even have to add it now if we'd done that in the beginning. And we'll start our angle out at 0. Now what we're going to be using is a little bit of trigonometry to control the movement of our projectile. So it's actually going to get a whole lot easier. So we can just take all of this WASD stuff and just get rid of it. Don't need it anymore. So what we are going to do with our projectile is we need to figure out what is that angle. So the projectile should still become active when we fire it. We want to set its location. In this case, I'm setting it equal to the center of my player. If you want it to be offset from the center, that's, again, your project, you do you. Now we'll say our angle, in this case, we need to figure out what we're using here. And the one we're going to use to calculate the angle between 2 points, the mouse and the player, or which in this case is also the projectile, to calculate what that angle is, we use arctangent 2. So A tan 2. And if we go into the help document for processing and look up under math arctan 2, the example it shows is how to calculate the distance between the mouse and a point. So it gives that to you. The thing that's different about using arctan 2 is our first parameter is a y value, then it's followed by an x value. So we'll say mouse y, and we subtract from that the y of this new projectile that's being fired. Then we say mouse x, and we subtract from that the x value. So we could have y minus mouse y and x minus mouse x. It doesn't really matter. The angle is still the angle. So it doesn't really matter which one we put first. And then now we need to calculate our Vx and our Vy, and that's why we're looking at SOHCAHTOA here. So when we look at SOHCAHTOA and we look at it, so if we're moving out in a direction like this with the right triangle, we have the hypotenuse of the triangle is 1 unit. So we can say that, if we gave it a measurement of 1. So now if we get like almost horizontal movement and look down below, we can see how that the adjacent is now 1 and the opposite has a value of 0. Well, our angle in this case is also 0. So sine of our y value, where we calculate our vertical component using sine. So it's sine of the angle. If we know the angle, it's going to give us opposite over hypotenuse. So we know what hypotenuse is, that's our speed. We know the angle, we're trying to figure out the opposite section in that triangle. So sine is used to give us our vertical movement or our y movement, and then cosine has adjacent in it, and that gives us a horizontal vector. So we're able to use these to figure out how to do it. Now the value that we get back in this regard is in radians. So we're able to plug that into sine and cosine because they want to use radians, not degrees. Otherwise, we have to do a conversion with it. So what we're trying to figure out is our Vx. In this case, it's that adjacent value, that horizontal movement. So Vx is going to be, well, we have cosine, adjacent, and hypotenuse. So we want to know what adjacent is, that unit. The hypotenuse is our speed, in this case 10, and then the cosine of the angle. So if we just take the cosine of the angle and so we have cosine, angle, and that gives us what we need, but we need to give it a little extra velocity. So this is where we'll use our speed factor. Vy is equal to sine angle times speed. So that takes care of the projectile. And now what we need to do is we need to make it so that I can press the mouse to do that. So we'll just close this. We're done with our trigonometry. See, math doesn't have to be scary. And we need to figure out, when we're firing, how to work with it. So we're not going to use our current direction anymore. So we comment that out or even just delete those. Might as well delete it because we're not going to be using it. So let's delete that. And what we need to do is we want to tie it into the mouse being pressed. So to do that, we want to create a way to track when the mouse is being pressed, when it's being released, and then tie it in on the firing timer. So with that, I'm going to add in 2 extra utility functions here. Void mouse pressed. Let's see, it turns blue just like key pressed. So it's a built-in method. And then we'll have the mouse released, but because it's almost the same here, I'm going to create a Boolean here. Well, I'm not creating it here, I'm defining what it's going to do. We'll create the released one, then we'll go actually add that variable to our project. So now this is released. And then when we release, it's false. Now OK to fire is underlined red because we haven't defined it yet. If I read the error message, it would have told me that. So let's now go here and say Boolean OK to fire. Now let's go and define that. And as I mentioned, like our setup here is not going to be the most organized thing. When we're all done with this, you will want to take it on yourself to do that. But for now, it is going to be a little bit messy because we're just going to kind of keep adding to the end of it unless something requires us to do otherwise. We're not using current direction anymore, so I can delete that out of there. If you leave it in, no harm, no foul, but it's just extra code we're not using. And I'm going to say OK to fire is going to start out at false because we're not pressing the button. So it starts out at false. So if the firing timer is complete, what we can do is say and OK to fire is true. Then we'll set it immediately to OK to fire equals false. And what this will do is limit things, because if we tie it in just with the mouse press, we run into some issues with the firing timer not necessarily engaging in its proper manner. So now we can see I can press the mouse and it is going. Now as I'm pressing, if I feel like I'm able to fire too quick, whoop, see where it responds after I lose my health. Okay, so we can shoot. If they don't shoot at us, we're going to deal with, it's just a swarm behavior with the enemies, and we'll make it so that the boss ends up firing at us. But now we've added in mouse point shooting as a new feature into our project. Good luck and happy coding.